Hello, so today we are going to do this problem, which is part of Leetcode Daily Challenge, keys and rooms. So we have n rooms that are labeled from 0 to n-1, and all of the rooms are closed or locked except room 0, okay? And our goal is to visit all these rooms, right? We cannot enter a locked room if we don't have its key, okay? So how do we get the keys? Each room has a set of distinct keys in it, okay? And each key has the number of the room that it opens, okay? So we get the array of rooms, and in each room what key is in it, and we want to check if we can visit all the rooms, right? So for example here that means room 0 has key for room 1, room 1 has key for room 2, room 2 has key for room 3, and room 3 has key for room 0, 1, 2, 3 for room for no rooms because the list is empty, right? So can we visit everything here? Yes, we can, because we can visit. We start from room 0 because that's the only choice we have. It's the only one open, and so we go from 0 to room 1 because it has the key, and then we go from room 1 because we have the key for 2. We go to 2, and since in room 2 we have the key for room 3, we go to room 3, right? And so that's that way we visit all rooms. So this one is valid. For the second one, if we take a look here, room 0 has the keys for 1 and 3, room 1 has the key for those, 2 has the keys for those, and 3 has these keys. If you try to do it, we cannot enter room number 2, okay? Because the only you take a look here, there is no key for room 2, no key for room 2, no key for room 2. Okay, it has its own key in itself, so there is no way to enter it, so we return false, right? So that's the idea. Now how do we solve it? Now you can see here the goal is to visit all nodes, right? And in each node all rooms basically, in each room you have which rooms you can go to. So this is sort of like a graph, right? But also a directed graph, because 0 to 1, this means from 0 you can go to 1, but doesn't mean from 1 you can go to 0, because 1 is initially locked, so you can't go from 1 to 0 because yeah, you can't, okay? Same thing here, 1 to 2, that means you can go from 1 to 2, but you can't go from 2 to 1 because you don't have the keys for 2, right? So that's the idea here. It's a directed graph, and so we can run any of the graph traversals, whether it's DFS or BFS, to check if we can visit everything. And by default we have a visited set that can give us how many rooms are visited, right? So yeah, let's do that. So we said it's a directed graph because this here means you have, for example here, you have an edge from 1 to 2 but not from 2 to 1, right? So that's what we'll do here. Okay, so first let's create our directed graph. So we need a graph. So we can just use a map where each node points to a list of its neighbors. So this would be a list like this. Now we wanna, so I is the index of the room and the keys in it, right? We can obtain that by going through rooms and then going through each neighbor and adding it to the list. So we can just say graph of I, right? We can just add the list of keys because those are the neighbors. Okay, so now that we have our graph, we can start our DFS, DQ. So we want to add from the front. It's a FIFO for BFS because we want to get the one that we added first. We want to get it out first because remember in BFS we visit level by level, so we want to finish the level we are traversing first and then start traversing the next level. I mentioned that in a previous video, but the idea here is that you want to visit the current level first, and then you visit the next level. And so to do that, you just add the current level to the front of the queue, and this one after it. That way, when you pop from the front, you will get all the current level nodes before getting to the next level nodes, right? So that's the idea of that. Now we want to go through the queue. While queue, we want to pop left, right? So this would be the node. And we want our visited set because that's what, first, because we don't want to visit a node multiple times, but second, that's what will allow us to see if we visited all the rooms or not, right? If we have if the length of the visited set is equal to the number of rooms, that means we visited all of them. So let's actually just do that. So only if the length of the visited set is equal to all the rooms. How do we determine all the rooms? Well, it's just the length of this room's list, because this room's list has a list for each node, for each room, right? So it's just the length of the room equal to the length of the rooms. And here we want to add to the set that we visited node. And we start from 0 here because it's the only room that we can enter first, because it's unlocked, right? And we need to define, of course, our visited set. And then we need to go through the neighbors. So for neighbor in graph of node. Then if it's not visited, then we want to add it to our queue in the back of the queue again. And now that's pretty much it. So let's run this. Okay, so that passes. Now, one thing you notice, so this is, one thing you notice is that this graph here, we actually don't need it, right? We can just here, instead of doing graph of nodes, we can, the neighbors of each node are just the list that you have in that room, right? And so we can just say of node, right? And that will give us the same neighbors that we had here, right? So we don't need this. And we can just run this. Submit. And that passes as well, right? Yeah, so pretty straightforward application of BFS. You can also do DFS or any traversal for a graph. And that should get you the same result. Yeah, so that's pretty much it for today's problem. Please like and subscribe, and see you on the next one. Bye.